This is a gate problem from circuit theory for an electrical engineering paper, and the question primarily deals with the steady state behavior of the circuit. So here is the problem statement. In the circuit shown in figure, the switch is closed at time t equal to 0. The steady state value of the voltage Vc is option A 0, option B 10 volts, option C 5 volts, and the last option is 2.5 volts. This is the corresponding circuit. So here is the switch which gets closed at time t equal to 0, and with steady state value of the voltage Vc. So if they are only interested in the steady state operation, we are assuming that the time is large enough so that the transients have settled down and your circuit is operating in a steady state mode. So under steady state operation, if you have a DC source, remember that the capacitive reactance is given by S times L, and therefore because a DC source has a frequency of 0, so omega is equal to 0, the inductive reactance will be having an absolute value of 0 ohms. So this is a short circuit, whereas the capacitive reactance, it is given by 1 by SC, and so if omega is equal to 0, this becomes 1 by 0, which means in terms of its absolute value, the capacitive reactance will have infinite ohms, or it will behave as an open circuit. So all you have to do is to remember this fact that at steady state, the inductor will behave as a short circuit, or you can replace it with a short circuit, and the capacitor will behave as an open circuit, and so you can replace it with an open circuit or infinite ohms. And therefore, if we go ahead with those substitutions, this inductor will become a short circuit, resistance remains as it is. Here there is a short circuit and an open circuit, and here is one resistance, and parallel to it is an open circuit. And this is the voltage that we are interested in. So it turns out that this is the voltage which is parallel to this 1 ohm resistance. And so if we look at the entire circuit, this is nothing but a voltage divider, because here is one voltage source of 10 volts. Then you have this resistance of 1 ohms. And then over here, there is a short circuit from that inductive component. And then here is another resistance 1 ohm. And parallel to it, you have an open circuit from this capacitor. So 10 volt source, one resistance, another resistance, and we are interested in this midpoint voltage. So this is simply equal to 1 ohms by 1 plus 1 ohm multiplied by 10 volt. So this Vc is equal to 1 by 2 multiplied by 10 volts, which is equal to 5 volts. So in this question, option C is the correct one.